came in, there was only 2 people, and I said, okay, no, we'll have a session just for 2 people.
Yeah, we have a lot of people coming, right?
So it's good to see a well-attended session. So may I ask how many people here are actually in the lab, day in and day out, working on a bench? Most everybody? Okay, students, postdoc, technicians, supervisors, PIs? No? Okay. So for the most part, we're going to talk about what we, people who work in the lab, need to do to make sure that everything that we do minimizes the risks to ourselves and to our laboratory coworkers and to the community. For most of you that work in the lab, or even if you're not working in the lab right now but have some experience, what I'm going to tell you is nothing new. You're going to be sitting there going, yeah, oh yes, I know, yes, I know, oh yes, I know. But what's important is that the things that we know that we need to do and that we should do, that we put them in practice. And we don't put them in practice just tomorrow because we talk about it today, but this is something that we need to do each and every day and every time we're in the lab working with anything that might possess even small risk. Okay, so biological safety is very important, as well as chemical safety and as well as radiation. For the most part, I'm going to be covering biological safety today, and I will just say a couple of words towards the end about chemical and radioactivity. So every time we work in the lab, we have to think it is our obligation to protect ourselves, anybody who comes in contact with us, the community, and the environment. You might think that you're doing something very safely, but you might walk out if you don't wear protective clothing, for example, the lab coat, and then you decide that you want to walk down Tulane Avenue wearing your lab coat because you look cool, and you might be spreading some sort of infection. Here I see a bunch of people with lab coats. That shouldn't happen. If it's a lab coat that you're wearing, it's nice, clean, you haven't used anything dye-hazardous, yes, it's okay. But as a general practice, your PPE is worn in the lab, you take it out, and then you work, and you walk out with your street clothes. So the most important thing that you can do to protect yourself and to protect those around you is to be informed. You need to know what you're dealing with. And once you know what you're dealing with, you're going to become very knowledgeable about that particular biohazardous substance or agent. You're going to be compliant with the institution, with Tulane regulations, with federal regulations, and with local, state, and local regulations. And the third thing that you have to do, if anything happens that you think it put you at risk, if there is a spill of something biohazardous, don't think, I really messed up, I better not let anybody know because I'm going to look very incompetent. No. The first thing that you have to do, if you think something has happened, a spill or a procedure or a chemical reaction that you might suspect it might have bad consequences, you need to report it immediately. Immediately. Don't be afraid, just call. Your direct supervisor is the next person. If that person is not available, whoever you can reach, the next person after that, another faculty member, the chair of your department, and then I will tell you how it goes after, who you need to report. But very important, be informed, comply with everything, and report. And so for Tulane University, we have what is called OEHS, the Office of Environmental Health and Safety. And all you have to do is go to Tulane website and type OEHS, and then you get all this information here. They have been working on the page, and they reorganized. It has all the programs and services that they do, education forms, posters, etc. All the information that you do is here, that you need to know from the OEHS office is in that page. They don't come knocking on our door saying, let me teach you about how you need to handle things in the lab. You go there and you find all the answers, okay? And, They give you the contact information, and then here, I know you can't read it very well, but you can actually call the person in charge of specific things. So like animal research, you're working on an animal and then you don't know how to handle that particular strain. It's a rat, it's a mouse, it's whatever. What kind of precautions do you need to use? You can call them and they can help you. The IACUC can help you as well. But, asbestos, chemical inventories, chemical safety, there is a person in charge of that. If you don't want to go through that list, just call and they will give you an answer. The other option, that was OEHS. The other office that you need to be aware at Tulane is the Office of Biosafety. And the Office of Biosafety just deals with biological hazardous materials. The OEHS does environmental, chemical, bloodborne pathogens, etc. Office of Biosafety is just biological materials. Also, there is a very nice web page. You can go there, obtain all the information, obtain information about the organisms that you might be working with. Do you need special permissions or training to work with those organisms? Is your laboratory certified to work with those organisms, etc.? And if you don't find the answer, then you can call them and they will tell you. There is also the Institutional Biosafety Committee. I am the chair of the Institutional Biosafety Committee. And that committee is composed of faculty members, of our research compliance officer, veterinarians, members of the community. And that committee is in charge of, first of all, complying with NIH regulations, because NIH gives us a lot of money. And most of us are here because the NIH gives us money, because otherwise we don't have money to pay our salaries. And the NIH says this is what you have to do. So they regulate, for example, the use of recombinant DNA materials. And so they tell us what we need to do, what we need to report to them. And so the Institutional Biosafety Committee is in charge of making sure that all the investigators comply with those regulations. At Tulane University, the IBC is also in charge of oversight of other projects that involve biohazardous materials, even if they're not, even if they don't have recombinant DNA. Okay, so for example, research with the bacteria that causes tuberculosis, even if it's not recombinant, we review those protocols and make sure everything is done in a proper and safe manner. So that's the Institutional Biosafety Committee page. We also have a page. It tells us what we do. It tells us our policies. It guides you as to whether the work that you're doing needs to be registered with the university or not, because there are a lot of things that are exempt. And a lot of the things that we do around here are exempt. You need to know if what you're doing is exempt or if you need to register with us. So go to those pages, and then if you don't find the information, pick up the phone and call us, whether it's for biosafety, for recombinant DNA, for OEHS. And that's just the information for that. And also, if you're not sure, if you want to learn a little bit more other than Tulane, go to trustworthy online resources. Not everything you read online is true, because you haven't noticed. So go to trustworthy sites, CDC, the World Health Organization. They have a very nice laboratory safety manual, the NIH, and the American Biological Safety Association, or ABSA. Canada and Australia also have really cool manuals for biosafety. The government, not just any Australian dude, just the government sites. So very, very nice information. The CDC publishes this, which is, it's the BMBL, Biosafety, Microbiological and Biomedical Laboratories. This is the 5th edition, which was updated about 2-3 years ago. For a long time, they didn't update it. But they published this. If you write to them, they send you this little book for free. And here, and if not, it's online. It's a PDF. It takes a little bit to download because it's a lot of information. You can download it, and then you go, well, my PI just told me I'm going to be starting working with Pseudomonas. I don't even know what that is. Let me read about it. Okay, so this is a very good resource, and it's free.
Who publishes that?
CDC.
Okay.
Yeah, it's on the CDC page, and if you go to that site, then you find it. You can download it. This actually, I got this on a meeting. They were handing it out, but somebody told me if you write to them, they send it to you. Maybe they charge you shipping. I don't know. So what are the normal, most basic principles of biosafety? First of all, you have to identify the type of biological hazard, and you have to evaluate the hazard and determine how you need to work with it. Then you need to institute safe practices, which physical and what type of barriers you're going to establish so you don't get exposed, or you don't make other people get exposed. And then you need to determine how you're going to handle, for example, waste, which contains biological hazardous materials. And finally, and as I already said, how you will report anything that's reportable. So why is this important? This is something that was published in the New York Times in 1997. I know it's hard to read, but I'm going to send the presentation so you can see it. A drop of virus from a monkey kills a researcher in 6 weeks. How many of you are familiar with this case? How many of you work with non-human primate samples? Nobody. Okay, but we have a primate center just across the lake with 5,000 monkeys, and you might at some point have to deal with monkey samples. And if you don't, maybe in your next job. So anyway, this is a case from a young researcher, young lady, who was working at the primate center at Emory University, associated with CDC. She was doing everything she was told to do. She was wearing a lab coat, she was wearing gloves, and she was wearing a mask. And she was in charge of dealing with the monkeys. And they had told her, if you have to minimize the possibility that a monkey will touch you. And so there was a cage with a monkey in it, and the cage had a very thin mesh, so the monkey couldn't reach out to grab her. The monkeys are nasty, nasty, nasty. They will reach out and try to grab you, and they'll... Okay, so there was a mesh. The monkey couldn't do that. And it was a small monkey. She was going to move the cage. At some point in this process, the monkeys clashed something. It's not known what. Could have been urine, saliva, a little bit of excrement, and she felt a little drop in her eye. But, it's no big deal. Okay, well, I wear my gloves and she died 6 weeks later. Monkeys carry a virus called monkey B virus. It's a herpes virus. They carry it sometimes asymptomatically. Sometimes symptomatically, we can see it, but sometimes asymptomatically. And they survive. It doesn't do anything to them. To them, it's like herpes virus. For us, a little sore, but it's lethal for humans. And so this happened to this girl, Elizabeth Griffin. There is something called the Elizabeth Griffin Foundation that they are funded to enhance laboratory safety, et cetera, and it's an honor of this girl. So I tell you this story because sometimes we think we're doing everything correctly, and however things can happen, perhaps because we don't know. And so it's always the right thing to do is always be more cautious than we need to be. So in that case, nobody blame her, of course, but she would have said, "Oh, I'm going to wear goggles just in case." So important to know what you're dealing with. And for you, I ask how many people are in the lab. So sometimes for young people, students, not necessarily postdocs should be pretty knowledgeable, but students, you walk in the lab and they say, "Oh, we're working with this, just go ahead and do it." Take the time to inform yourself. If your PI doesn't tell you, if the supervisor doesn't tell you, go online and find out. Find out as much as you can about what you're dealing with, the nature of the hazardous materials before you feel comfortable working with it. Okay, so you have to identify what is it that you're working with. Infectious organisms, toxins, allergens. Are you working with human samples? Are you working with urine, with blood? What is it that you're dealing with? Are you working with things that contain recombinant DNA? Are you working with unknown samples? Because unknown samples sometimes contain things that you have no idea what it is, so you have to treat those actually with great respect. So figure it out and assess the risk. Identify it. Okay, if I know I'm working with Neisseria meningitidis is an organism that causes meningitis. And if I get exposed, am I going to use sharps? Am I going to use a syringe? And if I prick myself, what's the outcome of the exposure? And what can happen to me? If there is a spill in the lab, what is the outcome of that? What can happen to the person sitting next to it? And then think about what you will do. The good thing is that what we call laboratory acquired infections, considering so many labs in the country and so many people working with biohazardous materials, the incidence is actually not as high as we would expect. But there are a lot of incidences. And so always determine the risk of level of the agent to personnel and environment, containment facilities, safety controls. What can you do to minimize, and what would you do if there is an exposure or a spill? The last report, like comprehensive report in the country for laboratory acquired efficiencies, is from 1999. Somebody needs to write a new one. I don't know, but somebody needs to write a new one. But they made a really comprehensive analysis, and I don't think this has changed too much. The most common organisms responsible for laboratory acquired infections are tuberculosis, hepatitis, Neisseria meningitidis, Salmonella, Shigella, Brucella, and Klebsiella. So if you don't work with any of those, it doesn't mean you don't have to worry about, but if you work with those, let's just be a little bit more cautious. So who assesses the risk? UPI is in charge. But a lot of times, the PI is in the office writing grants or doing other things, so that you are the operator. If you are the operator, it is your responsibility to be informed. Now, the biosafety office helps you with that. The institutional biosafety committee will help you with that, but it's you, the person who's day in and day and day, pipetting, injecting the animals, transferring materials, et cetera, et cetera. At the level of the government, the Office of Biotechnology Activities, or OBA from the NIH, the Recombinant DNA Advisory Committee, also if you go to their pages, they give you a lot of information. The National Science Advisory Board for Biosecurity as well. Those are all government offices. And so, when you work with an organism, the first thing that you need to determine is go online and figure out what risk group this organism belongs to. And these risk groups are determined by CDC and the government, and they go from risk group 1 to risk group 4, with risk group 1 presenting the least risk to risk group 4 presenting the highest risk. And so if you go, it'll tell you it's E. coli, and most of us, if you're doing cloning, whenever you work with E. coli, it's going to tell you E. coli K12, which is what most of us use for cloning, is a risk group 1. So those are agents that are not associated with disease in healthy human adults. The emphasis in healthy. So if you or somebody who you work with is immunocompromised for whatever reason, or they might be diabetic, or, or even a person who's pregnant, then, you have to consider those as immunocompromised, even if they're not HIV patients. So just be aware of that. Risk group 2 are agents that are associated with human disease, it causes disease, but it's rarely serious, and for which you can be treated easily. So, you acquire an infection, you get some antibiotics, that's fine. Now, I work with Shigella. Shigella causes a really nasty diarrheal disease. But if we get it, sends us to stay home for a couple of days, not too far from the bathroom, lose several pounds, and then treat with antibiotics, and then you're fine. So, it's not going to kill you, unless if you're immunocompromised, it could kill you. Risk group 3, agents that are associated with serious or lethal human diseases, and for which we might have preventive or measures or therapeutics. And risk group 4 are those that cause very serious disease lethality, and for which we don't have treatments or preventions. Okay, we don't have any of those at today, thank goodness, but we have 3, 2, and 1. So depending on what you're working with, the Office of Biosafety and the IBC is going to determine, or your PI has to determine what is the level of biocontainment. So the levels of biocontainment go from biosafety level 1, BSL1, to biosafety level 4, with increasing stringency from 1 to 4 as to what you can or cannot do in these labs. So biological safety level 1 is probably what all of us did when we were an undergrad. You know, a little bit, we play a little bit with reagents, with organisms. If there is a spill, it really doesn't possess any big risk. We wear lab coats just to get used to it. You deal with things like bacteriophage lambda, E. coli, etc. BSL2 is most of the labs here are BSL2, as well as the labs in the upstairs in the vivarium. And so you have everything in terms of biocontainment in the BSL1, plus other requirements. So for example, the access is restricted, there is no drinking, there is no mouthpipe painting, there is never mouthpipe painting, never mouthpipe painting. You always have to wear your PPE, your laboratory coat, your gloves, etc. When you walk out of the lab, you leave those things behind. So most of you, about 90% of you work in BSL2. If you're not sure if your lab is compliant with BSL2 and you go, I don't know, I know I'm new and I'm not sure, just call the Office of Biosafety and ask. You know, there are certain things that shouldn't happen. For example, if you see a bug, we're supposed to have all the labs under, we have a insect control, so there shouldn't be roaches running around. I know we're living in the country of roaches here in New Orleans, but just some things even that you don't think it might possess a risk, just report it, you know, call it. If the postdoc says, oh, we've always done things like that, you don't have to wear gloves to deal with this, and you go and look, and you check in the BMBL, and it tells you that's a risk group pathogen, well, then listen to that person, even if that person has 10 years of experience in you. Wear your lab coat, wear your gloves, wear your goggles. Err on the side of caution. BSL3, all the BSL2 practices plus. You need special training. You cannot work on BSL3 unless you're trained for it. Mandatory PPE, no longer recommended. You will never walk out of a BSL3 with a lab coat. You have to strip in, change, put scrubs, work in the BSL3, come out, take everything off, take a shower, walk out. We have to have biosafety manuals as to how to operate a BSL3, standard operating procedures that you have to follow step by step, etc. At Tulane, we have BSL3 labs in the primate center. At this point, only in the primate center. We are trying to get one operational here in the 5th floor. That might happen within the next 6 months, although we've been talking about that forever, and it hasn't happened yet. For those of you who work around here, if that happens, just be aware of the fact that serious organisms are going to be handled right here, right around the corner. BSL4 is what you see in the movies like Contagion and like, I don't remember, what's that movie with Dustin Hoffman and the little monkey and, everybody is. Okay. Yeah, well, we don't have that. We don't have that here. Tulane, there are a few around the country. I'm proud to say that one of the BSL4 labs that works with some of the most serious pathogens is the Rocky Mountain Labs in Montana, and the manager of that facility is one Tulane alumni, actually from my department, which is awesome. But we don't have that in Tulane, which is a good thing. That's where you would need to deal with Ebola or Marburg or organisms like that. Okay, and the same that biosafety levels just for lab work, there is the same, it's called ABSL, and that's for animal work. So ABSL1 is for animal work, a level 1, ABSL2, animal work, a level 2. And this also is a little bit confusing because this is also used for arthropods. So right here, I don't know if any of you work with mosquitoes, infected mosquitoes. So arthropod biosafety level 1, arthropod biosafety level 2. If you're working mosquitoes and the mosquitoes are infected with something like West Nile or whatever, you need to have a containment. And it needs to be a serious containment because the damn mosquitoes are going to fly out of the lab. We don't do this at Tulane, not even uptown, but if you happen to be in a place that they work with plants, it's really important to have biosafety containment, because if you have a virus in plants and it escapes, you can, eliminate the whole crop of rice in Louisiana or something horrible like that. So you need to take it seriously. So always wear your PPE. Be aware of aerosol producing activities. Always working with biosafety in the biosafety cabinets if it's deemed appropriate. And then so this is what we do ourselves. These are our practices, and this is what your place of work does. So Tulane, it's the buildings, the laboratory design, the providing autoclaves. This is a BSL-1 lab, this is a BSL-2, this is a BSL-3. Tulane establishes that. How the ventilation occurs. So the labs that work with biohazardous organisms should have a negative pressure. What that means is the air gets pulled in the lab, not pulled out of the lab. Because you might, if you're walking by a hallway and somebody opens the door, you don't want to be exposed to that. So negative pressure for the labs that work, particularly for BSL-3. I don't need to tell you the PPE. It's just make sure you wear the appropriate PPE. BSL-3, this is actually, I think this might be in our BSL-3. You need masks and N95s, or a lot of times what's the power assisted personal respirators, which is this, the hazmat suits, etc. We do have that at the Primate Center. Avoid aerosolization, always avoid aerosolization. Cap your tubes, do not vortex an open tube. Use the proper equipment. Always use the proper equipment. Do you guys know what this is?
Oh, it's a hood. Like that.
Okay, is a what?
Laminar.
A laminar flow hood, okay. What's the difference between this and a biosafety cabinet? How many of you have a laminar flow hood in your lab? You work with cell lines, et cetera, et cetera? Yeah, okay, so what's the difference between this and a biological safety cabinet? You would be surprised to know that I ask this question to the PIs and sometimes they don't know. Tell me.
Oh, well, I was just thinking that biological safety cabinet doesn't even have ventilations, or some do, depending on what you're going to use. And then you have the laminar flow, which is pushing it towards you, and then you have the other type, which doesn't push it towards you.
So exactly like that. You need to know what you need. So this is a laminar flow hood. This is pushing towards you. And so if you're you're going to work in a lab, and then they say, oh yeah, you're going to work with an infectious organism. Just sit and work there. You see where the air is going? The air is going to you. So these are designed to either protect the product. So if you're working, so what you're doing cell lines, right? You're not going to get contaminated with cell lines. You need to make sure those do not get contaminated. It's okay if it blows to you. So you use a laminar flow hood. That's okay. But if you're working with something that is hazardous, you move into a biological safety cabinet. If you don't have one in your lab, find somebody who has one and ask them to use. Make sure it is, because I've asked this to a room full of PIs, and they go, I have one in my lab. I say, no, what you have is a laminar flow hood, not a biological safety cabinet. A biological safety cabinets go from 1, 2, 3, and 2 has like 2A to B, whatever, you don't need to know all that. But as you said, it depends on how the air gets circulated, whether the air gets back into the room, whether the air gets filtered through HEPA filters, single or double HEPA filters, whether it's the ducts are hard ducts, et cetera, et cetera. So you need to know you're using the right one. If you don't know, you look at that thing, it's like, I don't know, it doesn't say here. Call somebody and ask. And make sure that if you have one, it's certified. Because we, the university, are supposed to send somebody who's knowledgeable once a year to certify that the air circulation in that cabinet is appropriate, and it needs to be certified once a year. So if yours has some date that says 1998 pre-Katrina or something like that, call somebody. Go next door. Use the next door, the lab that has that one that is certified. So HIPAA filters, the doors need to be self-lockable. Make sure that the eye wash in your lab works. Your lab chairs, they shouldn't have this sort of fabric. They should be something that you can spray with ethanol bleach, like not leather, because those are too expensive, but like leather, whatever. Something that you can spray. Not this. This gets contaminated and you never get it out of there. So the PI has to establish and implement the standard operating procedures, the good laboratory practices, the good manufacturing practices if you're making anything. They have to develop, document it, distribute it, update, and ensure compliance. So sometimes the university bugs the principal investigators. You have to do this, you have to do this. And so they get and they do it and they, and they did it maybe 3-5 years ago and then they never talk about it again. So you need to ask, where are our SOPs? How was this updated, et cetera, et cetera. For those of you who grow organisms, always ask yourself what is the minimum amount that you need. So even if it's E. coli, if you only need a plasmid or something like that, and you can get away with growing 10 mils, don't grow 100. Why? You don't need it, and then you might dump it down the drain, and if it's not properly decontaminated, it possesses a risk in the environment. So just always use, this applies to chemicals as well, the minimum amount that you can. I don't need to tell you about how to dispose sharps. You never recap a sharp. You need to dispose it in properly labeled containers that are made for disposing sharps. And if you get skin puncture, if your skin gets exposed to anything that is an organism that is replicating, you need to report it, or to blood products, whether monkey, and I already told you the monkey story, or humans. And actually anything, even if you're working with rodent blood, if the rodent has been exposed to pathogenic organisms, you need to report it. So how do you get rid of the contamination? Well, you can autoclave, you can use disinfectants, but you need to use the proper level of disinfection. So here you have organisms the least resistant to the most resistant. So if you're dealing with things like Staphylococcus, E. coli, things, then all you need is bleach and a little bit of 70% ethanol, 10% bleach, and then you're fine. As you go up the ladder into the most resistant things, fungi are there in the middle, non-lipid viruses, tuberculosis, and things that produce spores. For example, Bacillus anthracis, and I know none of you are working with that currently, but things that you can encounter, such as Clostridium or other organisms that produce spores. And these you have to autoclave, and you have to make sure that they have been properly autoclaved, because the spores are very, very hard to kill. Here at Tulane, we have this service. Always make sure that you throw all your contaminated stuff in there. Do not just wash your hands and, if it's not contaminated, and throw it in there, because that creates a lot of label boxes as biohazard, and all they have is water. So put it in the right container. If it's just water from the trash can, it's contaminated with something, throw it in there. So just as a recap, if there is an incident and you get exposed, most important, report to your immediate supervisor, to the blood-borne pathogen coordinator, if it was blood or bodily fluids, whether human or primates, to the Office of Biosafety and the IBC. If you feel that you need a medical evaluation, don't think about it twice. We have a physician that is in charge for Tulane exposures, but even if you don't know and you don't know the name of the person, just go across the street. If you're not sure, just...
I also have a question for a previous slide. So when you have those bins, what % of it can be biological material?
I'm sorry, say that.
When you have those bins,
yeah.
What % of it can be biological material?
As opposed to?
Let's say you have like, what is it called? Like bench pads, and you spill a little blood on it. It's like a little in the corner, but you have to put it in there because there's blood on
yes,
it.
Of course.
And versus being like completely saturated. So do you guys have the regulation at Tulane that you like only,
No.
certain percent of it, and then after you hit that percent of
No.
biological. Okay.
No. Just anything that you think it might be even a little bit contaminated goes in there.
Okay, but you don't have
Goes in
like a
there.
ratio. Like
No,
after
we
you
don't have.
hit
No, we don't have a
1%,
ratio.
yeah,
We
okay.
don't have a ratio. It's just more of a personal thing. If you realize that it's just something that is not contaminated at all, is the bags that you used to autoclave. You just took your instruments in there. These bags were autoclaved, and you just took your instruments out. And well, it doesn't need to go in there. It was an autoclave bag. You can throw it in the trash can. But if you have any doubt at all, throw it in there.
Oh, yeah, I was wondering, because
Yes.
someone mentioned that, we didn't know the answer to it. So I figured
Yes.
time
If
to
it's something
ask.
that it's nothing. It's paper. You just wash your hands. It's an autoclave bag.
Well, it was more of like versus like you have a thing that's 25% saturated versus 50%. If you're putting a bunch of 50% in there, you're.
And then there are things that you always have to dispose properly. So sharps, you take a syringe out, it's perfectly, it's sterile, and you didn't use it. Well, you're not gonna throw it in the trash can, of course not. It's a syringe, so you throw in the sharps. And by the same token, there are certain things we don't throw in the trash can just because the perception. For example, a petri dish. Don't throw a petri dish in a trash can because of the perception that, oh my God, that must be growing Ebola. Remember we have the cleaning people that come in the afternoon. They don't want to pick up a bag full of petri dishes, even if we knew that we just opened the bag and threw them there and they're cleaner than our plates that we used to eat at home. They don't throw them in there because of the perception. Yeah. So just use your judgment. Yeah. Okay. So I just wanted to say. Report it. Very important. Very important. How many times I repeat it? Just report it. I already mentioned, so the IBC deals with the use of recombinant DNA. So please, call me, call the Office of Biosafety if you're not sure. I'm using some recombinant material. Do I need to have a protocol approved? Sometimes the things with recombinant DNA do not even process a great risk, but they need to be registered with the university. So the NIH mandates that. And the NIH says any institution that receives money from us, they have to comply. If you don't comply, we could take your money away. As soon as they say that, crack the whip, everybody complies. But some people just don't know, and we try to disseminate information. So if you have a question, I'm working with E. coli, I'm growing a plasmid, and the plasmid has some ampicillin resistance, and this clone, we bought it, person LSU gave it to us, do I need to register? Talk to your PI, and, just call us and find out. A lot of these things are more for compliance than for biosafety, if they don't possess a risk. How many of you know about select agents? Does anybody know what select agents, what it means? Okay, select agents are microorganisms or toxins that the government, the Department of Health and Human Services, the DHHS, have put into a special category because they represent the most dangerous and the most likely to be misused intentionally to cause casualties, for bioterrorism, etc. So the government told the CDC, you figure it out, we're delegating this obligation to you. So the CDC has, they consult with a lot of experts, and they have made a list of organisms that are in this select agent list. If we work with select agents, we need to be registered with the CDC. They need to know what we have, and we are. Tulane is registered with CDC. We do use some of these agents at the Primate Center. So if you ever hear about this and you're interested, go and see. Of course, we have things there like Bacillus anthracis that causes anthrax, Yersinia pestis that causes plague, Ebola, Marburg, Junin, Machupo, all the nasty viruses that cause viral hemorrhagic fevers, etc., etc. And so because of that, we are very concerned with biosafety, which is what we're doing today. Also with biosecurity, these two things are different. Biosecurity are the processes that we implement to make sure that people that should not have access to these materials do not have access to them. So, the doors need to be locked, double locked, and our inventory for these materials are in freezers, for example, that we don't publicize where they are, and you need an accent. At the Primate Center, we actually have retina scans. So unless somebody stings your eye and you can't. So that's biosecurity. That's what Tulane has to make sure that nobody who's not supposed to have access to these things have access. And then the NSABB, which is the National Science Advisory Board for Biosecurity, dual use. Have you ever heard about dual use? Okay, let me tell you about dual use. Dual use is the government is very interested in dual use, which is things that we use in the lab day to day, perhaps, but they can be used intentionally with ill intent. For example, in our lab, we have bioreactors that grow, where I can grow 10 liters of E. coli. That's not gonna make anybody sick. It's E. coli that doesn't cause not even intentional intestinal disease. Well, somebody can take that same bioreactor and use it to grow anthrax. So dual use means things, procedures, protocols that can be used either for research or with ill intent. And they have this advisory board that regulates and say, well, if you have X in your university, you need to let us know. And there is they have an interesting webpage, but we have to comply with those regulations as well. Okay, so, what time is it?
I'm sorry. 13.
Or 15?
Yeah.
Oh, okay, okay. So we're going towards the end now. So one thing that you have to remember, most accidents happen because of human error. You know, because we weren't paying attention, because it's the last thing that we're doing at the end of the day, because we didn't know, because nobody told us and we didn't take the time to be informed. So always knowledge, common sense, and err on the side of caution. Always, always. And most accidents and exposures can be minimized. Now, I wanted to say just a couple of words about safety practices about working with chemical, radioactive, or physical hazards. So I always like the little news. UCLA researchers' death draws scrutiny to lab safety, and this happened in 2012. Are you guys familiar with the case? UCLA, young, beautiful, 23-year-old. The other one also was a 23-year-old girl. You know, I look around and say, what can I help you? This girl, I think she was an undergrad. She's working in the lab. She had not been properly trained, and she had 1.8 ounces. 1.8 ounces is little of N-butyl lithium. I think that's what it is. Don't quote me on it. You can go look it up. But it's a chemical that should never be exposed to air. And she had 1.8 ounces on a syringe. And when she was pulling it, she pulled too hard, and the syringe stopper came off. So the material was exposed to air, exploded, and killed her. She had not been properly trained. Something so simple, something with so little, 1.8 ounces, nothing. Her PI, this is the first time it happens in the history of our country, was actually the subject of a criminal case. I mean, he was accused of a crime. He wasn't even there. He was accused of a crime because he did not properly train this person. He was able to settle, you know, it's always the lawyers that help people, but he was able to settle. So he was able to avoid jail. But really, things like this can happen. This is a chemical, not a biohazard. And so don't, you know, it's like, oh, it's just an acid, it's just a base, I don't need to worry about. Always know. And in today's day and age, there is no excuse because everything is in the net. Everything is in the internet. So you're all familiar with the MSDSs, right? With an MSDS, you're working with a chemical. It used to be that we have to have these books this big in the lab, and you have to go there, you know, it's 4 o'clock in the afternoon, I have to make a buffer, you know, it's this hazard, and you're looking, well, now you just go to the internet and look, make sure that whatever you're using, you know what kind of hazard it presents. So no, again, no knowledge. What's the hazardous properties? Keep inventory to a minimum, so if you only need a little bit, don't order 500 grams. there's there is no need. Always know how to store things. You know, we have those cabinets for a reason. Acid, basic, strong oxidizers. Don't mix one with another. And you mix this with water. Make sure that you're using it correctly. Safely dispose of chemicals. We all hate this. Well, I hate it. You probably do too. You're using with the phenol, and then you have this big bottles, like it's just sitting there, you know, and I have to call OEHS, and then they're gonna come and tell me what I need to do, and it's just such a pain in the butt. Just do it, and don't mix chemicals. Because if you mix chemicals that are intended for waste, OEHS is gonna come and say, what do you have in there? And you go, waste. Well, what kind of waste? We don't know. Oh, we're gonna charge you a lot of money to dispose of this. But they're gonna charge you, they're gonna charge you PI, and somebody is not gonna be happy about it. So don't mix the chemicals and dispose of them as soon as you can. So don't store this, 3, 4, 5 gallons of phenol just because you don't have time. Just dispose of them. Once a week, once every 2 weeks. Don't keep that stuff around in the lab. And know what you have to do if a chemical spill occurs. And finally, we all used to work a lot of radioactivity. I don't think we do as much anymore. Anybody here works with radioactive? I would say, 20 years ago we all did. A lot of the cloning and a lot of the sequencing involved radioactivity. Not so much anymore, but some people still do. And if you do know that nobody can do any work with radioactive material unless you're so you need a license. So somebody needs to come to the lab, fill out paperwork. What kind of isotopes are you going to use? Is it going to be P32? Is it going to be tritium? What is it that you're going to use? It needs to be licensed. You need to have permission. You need to have registered on the radiation safety program, which probably involves wearing a dosimeter. Does anybody have it in the labs? You wearing your? No, not anymore. That's amazing. Anyway, if you do, you need to have something that it indicates. It's a radiation badge that indicates whether you have been exposed to radiation. And requires a strict inventory. Once a week, you have to go clean all the surfaces and measure if there's radioactivity. It's like, I'm glad we don't do that so much anymore. So, in conclusion, any of us, scientists, laboratory workers, supervisors, PIs, etc., who use biological, chemical, radioactive hazards, any kind of hazards, need to be knowledgeable of what we're using, so you will know how to handle it, how to store it, and how to dispose it. Always do things the right way. If you're not sure, ask. Put it off. If it's 5 o'clock in the afternoon, there's nobody to ask. Don't do it. If you don't know what you're dealing with, always ask, always report. Questions?
I have one question. You showed us the red bag pins for the biological hazards, but for the chemical hazards, is there any bags like this?
No, for the chemical hazards, so that's why so you have to read the MSDS, particularly when there is a lot. So if you're pipetting and you're pipetting, ethanol, 20 microliters, and you have a pipette tip, you can throw it in there. That's not a big deal. But if you have large volumes and it's biohazardous chemicals, you need to learn how to dispose of that. And so I gave the example of phenol, because phenol, people use a lot of phenol to isolate DNA, et cetera, and so that needs to be in a dark bottle, in a waste, and something labeled waste phenol, and you put it in there when that bottle is half full or something, then you call the OEHS and they take care of it. We don't do it.
When it's solid, like a gel. So
it depends. So for example, an SDS gel, I throw my gels in the bins, an SDS gel or a DNA gel.
So in the regular?
Yeah. No, not in the regular.
In the bag?
Yes. Even though it's not biological, but if you're doing something like ethidium bromide or, if it's an SDS gel that contains polyacrylamide, those gels are very thin, so it's not like a big chemical waste, so it's okay to throw it in there. But again, if you're...
that have been in contact with chemical or the Falcons and everything in the red box.
Mm-hmm. Okay. Yeah. But if you're not sure, if you know you're making a buffer and the buffer contains a chemical that you read the MSDS and it's like, oh, this sounds nasty, just call and ask. You know, for the most part, it's like sodium acetate, sodium hydroxide, little things like that. I'm sorry.
What about the PDF, the membranes for Western blots? Because they're supposed to be like flammable and.
Yeah, but I mean, you don't throw in a whole bowl. I'm just like,
yeah, I just wasn't sure if you wanted us to dispose them in a special way.
Yeah, that's fine.
Okay.
That's fine. You can throw them in there. As I say, that's something that perhaps it doesn't present any risks if you throw it in your regular trash can. But we don't want to be putting things in the regular trash can out there to Tulane Avenue. You know, people are going to go, it's like, oh, what is this? And then going to put us in the newspaper. Tulane University is not disposing of biohazardous material the proper way. So some of those things, like a Western blot membrane, it doesn't really possess a biosafety risk, but I throw it in the bin.
And even you're saying petri dishes, empty petri dishes? Or just
I don't throw those in the regular.
Okay,
those, I don't.
You want to put those in the red?
Yes.
Okay.
Yes.
Huh.
Because of perception.
Okay.
Yes.
It's the same for the gloves, even if you're ethanol, that's not dangerous.
I do. I don't think. You know, that's a good question. I should look at regulations, but I do.
Housekeeping will not pick up if they see a glove. They're not touching that whole can.
Yeah, that's the thing. You know, I love the lady that cleans up after. We're buddies because I'm always here late and she's always here late. And you know, sometimes she comes and asks me, and if I see something there, I say, don't pick it up because I don't know who the person was that used those gloves. I don't know, the person might have made a mistake. And even if it's something as simple as a salmonella, we cannot put the people that, you know, the people that are in charge of picking up the regular waste at risk. So like I say, even if I just use the gloves, I don't throw them in there because I didn't know that they actually tell them not to pick it up, right? Yeah, so.
I have another question, sorry. If you have a glass vial that contains a biohazard solution, where do you put that glass? Big biohazard trash or in the...
So it depends on what it is. So if it's, for example, if you're gonna throw it away, you're gonna throw this away, you don't need to recycle this. It's not something that you are gonna reuse. So if it's something biohazardous, such as it has an organism there, I put whether 70% alcohol or bleach or Lysol, something. So, and you need to leave it there for, it needs to be at least like 30 minutes contact. And then you can pick that up and throw it in the bin. You throw it in the bin. Yes. For certain organs. No, if it's broken, no. If it's broken,
if it's unbroken, if it's...
Yeah, you can throw it in there. But also an acceptable practice, and some people are surprised about this, but an acceptable practice is if you have organisms, virus, bacteria, fungi, and you decontaminate by either passing it through autoclave or 70% alcohol, et cetera, you can leave it there overnight, for example, and next day you can dump it in the drain. But I err on the side of caution. So if I'm just growing E. coli, I do that all the time, you know, because my 70% bleach and next I dump it at the drain. If it's virus, like a lot of people that work in viruses, they don't do that, even though the virus is already contaminated, it's already inactivated, but then just, you know, they might throw it in the bin. Yeah. So it's perfectly acceptable to throw it down the drain after it's been decontaminated. So either autoclave with bleach on it.
I'm also worried about the fact it's a glass bottle and it can be broken in the big trash can. It doesn't have to be put in the sharp object container.
So even if it's not broken yet, it could be.
It can be broken later. Yeah. I don't know. For my own lab, I hardly ever throw a whole big glass bottle. You know, you decontaminate them, you wash them. You know, you pass them through the autoclave and you wash them, you reuse them.
OEHS also has a service where you can call them when you have things like that, and they'll come pick it up, and they'll dispose of it. You just have to call and tell them what it is.
Yeah, you have to know what it is because even more than, they don't like that. And they charge you, they charge your PI.
And on the other side, so if you don't put glove, even if it's contaminated with ethanol in the regular trash, is it bad to put like wrapping plastic that are not contaminated, for example, the plastic bags around your petri dish in the red bag? Is it bad to do that? Because I know that people put everything in the red bag and food very quickly.
Yeah, I see, like the bags in which the petri dishes come. I don't put those in the bin. I put them in the regular trash.
But train charge the lab for that, or the numbers of beans?
No, not at all. But Tulane in general, it makes a difference, and I cannot tell you the numbers. I'm sure somebody knows how many of those boxes do we get out every day. So it would make a difference if we throw everything there. If we get, I don't know, let's say 200 as opposed to 500 or 700. Tulane pays a company that comes and picks up those bags, those boxes, to go and dispose of them properly. And the other thing I didn't tell you, please do this, because we've had to deal with the consequence of not doing it. When you fill up the bin and it's full and you tie it and you close it, label it. Label it. We've had to deal with, people come to pick it, if they come to pick it up and it's leaking and it's not labeled, so I don't know what's leaking, I don't know where it came from, what lab, what the heck did they put in there, and it's leaking. And they call, there's like, I'm not gonna pick up. They don't pick it up. They don't pick it up, so always label it. So things can happen, like you threw some liquid and then it leaked in there, but if I know if it says lab, room 57, doctor, I can call, and you're gonna say, oh, that was just water, or it's just so, or that had X virus, so we need to bring the bleach, But I've had to deal with that myself. Like, the people who are supposed to pick it up, they come and say there's a big pool of something under that box. We're not gonna pick it up, and then it has no label.
If there's even a water stain on the box from when they mopped the floor where the boxes were stored, they will not take it.
They will not take it, and then
Then what do you do?
the department has to deal with it.
You take the red bag out and you put it in a box that doesn't have water stain.
Somebody has to do it. I mean, I'm saying we've had to do it. The department people have to do it.
And when you do the box, then what do you do with the
You throw
box
it
you're
inside.
placing?
You pick it up and you put it inside.
You throw it inside.
You have to rip it up.
But it presents a huge biosafety risk because you don't even know what you're dealing with. So always label it, because nobody will know better than that lab what they were dealing with. And so if at least we know, we're working with nothing but E. coli, or that's just water, or monkey blood samples, at least people will know how to deal with it. So it's the kind of things that you did it and then you went home, and so you're free, but you're putting other people at risk. Always ask. All right. Any other questions? Okay, well, you know where to find me if you have any other questions.